Let's understand change in states of matter and evaporation in this video. Have you ever watched ice melt on a hot day and wondered why that happens? Or noticed wet clothes drying in the sun and felt a breeze cool your skin? Today we will connect these daily scenes to simple science. Matter can exist as three common states: solid, liquid, and gas. Which state we see depends on temperature and pressure. When we heat a solid, it can become a liquid, and with more heat, it can become a gas. Water is a good example. It can be ice, liquid water, or water vapor. Let us look at a quick classroom activity that shows this. Take some ice and put a thermometer so the bulb touches the ice. Heat the beaker slowly and watch the ice melt into water. You will see the thermometer read 0 degrees Celsius while the ice melts. Keep heating and the water will eventually boil and form vapor at 100 degrees Celsius. This experiment shows a key idea. Heating can change solid to liquid to gas. Now let us explain melting in simple words. In solids, particles are packed tightly and they only vibrate. When we supply heat, particles gain energy and move more. This added energy helps particles break free from their fixed positions. This change from solid to liquid is called melting or fusion. The melting point of ice is 0 degrees Celsius, which is 273 Kelvin. Next, when a liquid keeps getting heat, it reaches a boiling point and becomes gas. Boiling needs extra hidden energy to break particle attraction without raising temperature. This hidden energy is called latent heat of vaporization. For water, this latent heat is about 2.25 times 10 to the power of 6 joules per kilogram. There is also a latent heat for melting called latent heat of fusion. For ice, it is about 3.34 times 10 to the 5 joules per kilogram. Pressure also affects the state of matter. If we squeeze gases or cool them, they can turn into liquids, a process called liquefaction. Some solids like dry ice go straight to gas when pressure changes. This is special. Now let us cover other important changes. When gas cools and becomes liquid, we call it condensation, like water droplets on a cold bottle. When a liquid cools into a solid, that is freezing. Sometimes a solid changes directly into gas without becoming liquid first. This is called sublimation. Common examples of sublimation are camphor and iodine and dry ice. The reverse of sublimation, when gas turns into solid, is called deposition. Evaporation is when a liquid becomes vapor below its boiling point. Evaporation happens only at the surface because some particles have more energy and escape. Factors that change the rate of evaporation are the nature of the liquid, surface area, temperature, humidity, and wind speed. For example, acetone evaporates faster than water, and spread clothes dry faster than bunch clothes. High humidity slows evaporation, and wind or higher temperature speeds it up. Evaporation causes cooling because the fastest, hottest particles leave and the rest become cooler. That is why sweat cools us, and why poured tea cools faster on a saucer. We also see practical uses. Earthen pots keep water cool, and wet cloths help bring down fever. Finally, beyond solid, liquid, and gas, there are two more states to note. Plasma is a mix of free electrons and ions and glows in stars and fluorescent tubes. A special fifth state called Bose-Einstein condensate was predicted by Einstein and first made by Cornell, Ketterle, and Wieman at very low temperatures. So what do we learn from this? We learn that temperature and pressure decide the state of matter, and that heat can change one state into another. Let us quickly remember the main points: melting, boiling, evaporation, condensation, freezing, sublimation, and hidden or latent heat. So today we learned how matter changes state and why evaporation cools things. Keep exploring these ideas with simple experiments and observations around you. Thanks for listening, and do explore more lessons and practice on EduRev to learn at your own pace.